Welcome friends, I am Tanmoy. I welcome you all in my channel Chemistry and History of Molecules. Today I shall explain about a very basic name reaction, that is Gabriel-Phthalimide synthesis. Actually this method is important because it produces primary amine selectively. Okay? So what is the main problem of preparation of primary amine? If you react directly with ammonia and alkyl halide, it will produce primary, secondary, tertiary as well as quaternary ammonium salt. So we need to separate all of this and this is actually Hinsberg method of amine separation. I will explain this thing in a separate video. So today we will explain how to prepare primary amine selectively. Okay. So if we need to prepare primary amine, then we need to focus one thing, that nitrogen can form 4 substitution, just I have told. So we have to if fourth one is charged, so we have to block this at least 2, minimum to maximum 3. Okay. So how could we do this? We can block this part, and if we block 2 sides, then for neutral molecule there will be only one side left. So reaction will be selectively on the one side. You can ask that, okay, fourth. So concept is that instead of that, fourth is based on the lone pair. So if this 2 is attached to electron withdrawing group, then the third substitution is done. After that, the availability of this lone pair will be very less, such that this cannot participate in a further alkylation. And how this could be, availability could be reduced? First one is minus I, but more than minus I, which is important, is minus R. So minus R, through minus R effect, this lone pair will be delocalized within this electron withdrawing group, and ultimately it will not be available for further alkylation. So selectively we will get mono substituted amine. Okay, or we can say primary amine. So for this Gabriel method is done. What this? Generally first, this is the name of scientist Gabriel. This is the phthalimide reagent. Okay. So this is phthalic anhydride. This is phthalic anhydride. This comes from phthalic acid, which comes from the oxidation of naphthalene using vanadium pentoxide catalyst with atmospheric oxygen as oxidant. I have explained this in a previous video. Please go through this, then you will have the idea that how to prepare this reagent. And this reacts with primary ammonia or primary ammonia or urea as a source of primary amine. You know that urea could serve as a source of ammonia as a solid reagent, because it hydrolyzes this part and carbon dioxide goes out. Okay, phthalic anhydride, and this produces this phthalimide. Sorry, here should be a carbonyl. This produces this phthalimide, and this phthalimide, in presence of base like KOH, produces primary KOH first, and second step RH produces RNH2. That is the primary amine. Okay. So let's explain every steps slowly. So first, how ammonia reacts, and this reaction is done in presence of acetic acid. Acetic acid, and we know acetic acid is a weak acid, and actually this is, if I draw it properly, this is a reaction like nucleophilic attack on the carbonyl carbon. So nucleophilic attack on the carbonyl carbon, for we need to activate the carbonyl oxygen. This activation could be acid mediated, which will be added to this carbonyl compound, like this carbonyl plus acid will result in this protonated carbonyl. So if formal charge on oxygen, we know that this can undergo a resonance to form resonance where this bond will be taken by this and formal charge will come on carbon. So in this way the electron deficiency at this center enhances. First point. Second, how nucleophile should be stronger. We know ammonia is not a strong nucleophile. What is the strong nucleophile of which corresponds to ammonia is amide. Okay. So two strategy. One is acid catalyzed activation, another is base catalyzed. So this reaction is acid catalyzed activation. What happens? This acid protonates this. So formal charge comes on oxygen. So this carbon became more electron deficient. So ammonia attacks here. Okay, and it opens. So actually there will not be minus charge under acidic condition. It should be this. So here ammonia can lose one proton to be a neutral. Okay, this is amine. So when this amine is formed, it undergoes further reaction. Means, what do I mean? This can push and this will go. So what will be the product? So this will be carboxylic acid. Since this is in acidic medium, so it is true that actually if we write this negative charge will be consumed by the acid. I am skipping the step. It should be stepwise, but I am reducing the step. So this, and if it is, then this pushing could be from ammonia side, pushing could be from carbonyl side, both possible. Okay. So we are writing it in this way because if you see the product, the reaction of carboxylic acid with ammonia, it produces acid amide. Okay, this is an acid amide derivative. So what it will do then, since it is under acidic environment, so what happened? This can be protonated. You can argue that okay, why this position will protonate, this will protonate. I agree, that will. But this protonation is a equilibrium reaction, so this will protonate. Or you can say write in this way. You can write in different way also. That step you can right now you can write in this way that it will attack, it will leave one step strategy possible. So that will result this. Another thing you can consider in this way also, that protonation will not occur at this site. Instead of that, protonation will occur here. So ultimate what will happen? The electron deficiency of this center will enhance. So this ammonia at this condition can attack to produce OH, NH, and this. Is it visible? Yeah. So this is also possible. Now there may be one confusion. Why I am protonating oxygen rather than ammonia? Because nitrogen is more basic than oxygen. It's true. Protonation is a reversible. For example, maybe 80% nitrogen is protonated, 20% left, that 20% will perform the reaction. And since it is under equilibrium, so it is expected that it is under equilibrium, so it is expected that when this 20% will consume, from that 80% some will be reverted back into the amine. So in this way reaction will go on. So if it is, so this is under acidic condition, so acidic condition means it will be protonated again. So it will be protonated and this will push to eliminate. So ultimately it will produce this. Okay, so different way you can explain the procedure. So this is the explanation how this amide is produced. Okay, so this amide is produced right now. This. Now we have to focus the property of this amide. What do I mean? You can see this amide. This amide, let's compare with a relatively simpler example, benzamide and another is phenol. And if we look at that, its pK around 13. I request you, don't consider this value as 100% accurate. This may vary. Phenol is 9.9 pK and this is 8.3 pK. And if you consider acetic acid, pKa is around 4.7. So why I am saying this? Because next step is associated with the acidity. So here pKa is 8.3, here is 13, here is 9.3. Why it is 13? Because you can simply consider that this is in a resonance with one carbonyl group. That's why this is slightly more here with two carbonyl group. How? Because pKa means the stability of conjugate acid. Conjugate acid, what do I mean here? N minus. This is in resonance with this side, means one carbonyl, or it is in resonance with this side, so another carbonyl. So in this way, it is resonance stability. So that's why its pKa is even higher than phenol, because we know phenol, if we compare phenol with ethyl alcohol, to say that phenol is slightly acidic because of resonance, and this is slightly more acidic than phenol. So from here you can understand the reagent we have prepared, that is the phthalimide, is more acidic than phenol, but less acidic than acetic acid. So it's a mild acid we can consider, and that's why in presence of base like KOH, this deprotates to produce this minus K plus, and this minus is stabilized using these two. Okay, fine. Now you can see. So this is, but one thing, why we need KOH? Isn't it possible? Because previously we showed that ammonia plus Rx, then alkylation happens, primary secondary reaction. So it is possible that alkylation could be done using this ammonia. Then why this base is required additional? Because this nitrogen is attached to 2 electron withdrawing group. So the lone pair, which is actually responsible for the attack to that alkyl halide, is delocalized, no longer that much available to undergo this substitution reaction, not possible directly. That's why it is needed to generate this. So if I ask you how many lone pairs are there, actually here 2 lone pairs are there. One lone pair is this lone pair, and another is the bond pair of NH bond. When proton is abstracted, that pair remains on the nitrogen. So right now it is nucleophilic. Previously it is not nucleophilic. So what happened? If I produce Rx, then this attacks on the R and X leaves, means ultimately what actually leaves, Kx, is eliminated from the reaction medium. And in this way, this alkyl phthalimide is produced. But still it is not primary amine. Okay, we need to generate primary amine. How? We need to do hydrolysis, because you all have done that hydrolysis, alkaline hydrolysis of benzamide, what I have mentioned previously, that it produces ammonia. What reaction? PHCO NH2. If we boil with KOH or NaOH, it produces salt of carboxylic acid, that is benzoic acid, and ammonia. And in basic solution, ammonia comes out, which gives pungent smell. You have done this experiment, you know that. So similar, same thing should be done here. So if we take KOH, then OH attacks. Now previously I told that reaction between ammonia and phthalimide is acid catalyzed. So that carbonyl group is activated by protonation. And here the nucleophile is stronger, that is OH minus, so it is base mediated. Okay, so here nucleophile is stronger. So what will happen? So this will first produce OH, this, and NH2, NR minus. This is a strong base compared to this, so it will abstract the proton from here to produce NHO minus. This is, so then this will further undergo hydrolysis HO minus from QH, this, and ultimately it will push back. Then what will produce? RNH minus plus this ester, this salt of phthalic acid, K plus. Okay, this is, so it will abstract an ammonia from water molecule, hydrogen from water molecule, and produce RNH2. This is our primary. So this is the strategy of Gabriel-Phthalimide to prepare primary amine. Now, is it the ultimate one or is it the easy? Actually, this is not easy. Why? Because alkaline hydrolysis, 2-hydrolysis at this position is not easy to produce this. So what modification is done? The modification done is, instead of that alkaline hydrolysis, they used hydrazine. What do I mean? NR reacted with hydrazine. For example, hydrazine hydrate. So what it does, we know hydrazine is more nucleophilic than amine. Okay, because of alpha effect, that is the lone pair. This hydrazine both contains one lone pair. This lone pair repulsion, this became more activated nucleophile, and that is called alpha effect. And due to alpha effect, they are stronger nucleophilic than simple amine. So it attacks here, it opens up, and it comes back, it opens this. I am explaining this very fast. So because previously I have explained. So this hydrogen. So here O minus and this proton exchange I have previously explained. So I am skipping that. NHR. Okay. Now this is the important thing. Here in the second step, another molecule of alkali is going to attack here and this. So, but here this process, it is an intramolecular. So, intramolecular way, intermolecular reaction, this attacks, this comes and it leaves. So, ultimately what produces? Plus primary amine. So this process is more easier compared to the base catalyzed hydrolysis of this amine, alkylated phthalimide. Okay, so that's why this pathway is followed, because the hydrolysis is difficult. So okay, so this is actually the main theoretical discussion of this Gabriel-Phthalimide process. Now, is it here means what is the application? Because a name reaction you reading very much, so it must have an application. What is the application? The application is amino acid synthesis. Okay, application is amino acid synthesis. Okay, how? For that, let's first give the reaction scheme. Br COH, even Br chloro, this could be taken and it reacts, it attacks this and undergo hydrolysis in presence of hydrazine to produce this corresponding, I am not writing this, so to produce that COOH and NH2. This material is named as amino acid glycine. Okay, this is an amino acid. Others amino acid could also be done. How this reaction is produced? How this material is produced? This produces via HVZ reaction, where that carboxylic acid plus phosphorus plus bromine is reacted, and ultimately in between it produces PBr3, which undergo reaction here to produce this alpha bromo carboxylic acid derivative. This so how this amino acid could be from acetic acid to halogenation using HVZ reaction? This will produce this bromo acid, this alpha bromo acetic acid, and this will react with this to produce this. Even there is one advantage of this, because here SN2 is happening. Actually, this is a SN2 reaction, and this carbon have a carbonyl group attached. Here the SN2 is happening. So this carbonyl helps to accelerate the SN2 faster. I shall explain this whole phenomena in a separate video, because this video is going to be too long. So in this way, this reaction is happening, producing alpha amino. So this is one of the application. So what we have learned today? What we have learned today, the strategy to prepare selectively primary amine by blocking the two hands of amine or two valency of amine with an electron withdrawing group using this Phthalimide procedure. First. Second, we learned that attachment of this nitrogen with two carbonyl increases the acidity of that NH significantly, and this became acidic like phenol. Third, since its acidic deprotonation is easy, so deprotonation using a base produces this anion, and these undergo reaction with any alkyl halide via SN2 fashion to produce the alkylated species, and finally that is hydrolyzed either by alkali or by hydrazine. Hydrazine hydrolysis is better, as the second step is intramolecular and first step the alpha effect is involved for nucleophilic attack. That's why the process is easy. And finally, this process, this HBJ Gabriel-Phthalimide synthesis procedure could be utilized for the preparation of alpha amino acid. One of the example is glycine. Some other amino acid could also be prepared. So this is the end of the video. If you like my teaching, please give a like. Please subscribe my channel Chemistry and History of Molecule, and share this video among your friends, such that other people could get benefit from my effort. And finally, please press the bell icon to get the notification of every single video I upload. So see you in my next video.